Calculating the rate of descent. So a question. The rate of descent can be calculated by multiplying the gradient of descent by the ground speed, EAS, TAS or IAS. And the LO states describe the relation between TAS, gradient of descent, and rate of descent. So let's examine that, shall we? So here we have our glide path, and I think you'll see that the tangent of that is the rate of descent divided by the ground speed. That would be the tangent of that angle. So the gradient is the tangent. Now, we normally express as the gradient as a percentage, but we'll come to that in a moment. So the gradient is equal to the rate of descent over the ground speed. And just move that around a bit to get the rate of descent on its own, so that becomes the rate of descent equals the gradient times the ground speed. Now we've got a problem with units because the rate of descent we want in feet per minute and the ground speed is in knots, so we need to think about that. So the rate of descent we want in feet per minute, the gradient we'll come to. The ground speed we're given in knots, so to turn that into feet per minute I multiply it by 60/80 and divide that by 60 to turn it into minutes rather than nautical miles per hour. So the 60/80 divided by the 60 is approximately 100. So we could say that, and that's very convenient for us because earlier I just said to you we normally express the gradient as a percentage. So I could rearrange it just a little bit more to say that the rate of descent is equal to the gradient times 100%, so times the ground speed in knots. That's making it very easy now. So an example question. Given a gradient of 2.5%, so it's percentage, and a ground speed of 125 knots, find the required rate of descent. Straightforward. Rate of descent is equal to 2.5% times 125 knots, which is 312.5 feet per minute. So 312, I don't think you could actually fly 312 or 313 feet per minute that accurately. So it's as straightforward as that. Now, you might be given a glide path in degrees. So finding the rate of descent then for a 3-degree glide path, which is of course the most common of our glide paths. Notice the tangent of 3 degrees is 0.052. And if we express that as a percentage, it becomes 5.2%. So that's the gradient. So if I have a 3-degree glide path, it has a gradient of 5.2%. So just as an approximate ready reckoning thing, then we can say for a 3-degree glide path, the rate of descent is 5 times the ground speed. So simply find the required rate of descent for a 3-degree glide path at 125 knots. That is going to be 5 times 125, 625 feet per minute. If you wanted to do it on your CRP5, we can do it. So small angles, the gradient is approximately, take the angle time divided by 0.6. And 3 degrees divided by 0.6 is 5, so that's the 5 we had before. So 3-degree glide slope is a 5% gradient. But we can take advantage of that on our CRP5 and find the rate of descent for any glide slope. So given a glide slope of 2.5 degrees, remember the last one was percentage, 2.5 degrees, and a ground speed of 125 knots, find the required rate of descent. So on your CRP5, set the black triangle under the glide slope angle, and the black triangle is 6, notice, points, so that's the 0.6. And then against the ground speed of 125 knots on the inner scale, read off the rate of descent on the outer scale, 520 feet per minute. And that's it. You might want to go through this a couple of times just to get used to it, but it's not difficult stuff. Good luck.